Hey everyone, so let me show you what we're dealing with here. We're just going to try to make some basic measurements of density and average particle size. I've got a handy little mic here. I know it's a little bit loud in the lab right now. I'm going to run it through an audio smoother and see if I can't get rid of some of that background noise. But let me show you what we're up against here, what kind of stuff we're dealing with. I'll pull my microphone around with me, and I'm just going to move the camera a little bit. So the setup that we've got here is we've got 4 different types of spheres. So we have some very large copper balls, some medium-sized copper balls, smaller copper balls, and then glass spheres over here on the end. Our regular stocks are back here in the back, so if we need more, we can always go to those. But up here on the front ones in each of the smaller beakers, I've already counted out 100 of each sphere. So we know that there's going to be 100 of each of these that we're measuring. We've got a little bit of water back here in the back, so we can use that for whatever we need to, and a couple of graduated cylinders that are going to be our usefulness, or our tool that we're going to use for measuring volume of water displaced. And then we've got our friend the Mettler Toledo here, which if you can see around the glare, it's a little bit hard. There you go. It's got 1 digit of precision on it. That should be plenty for everything we're dealing with. But I'm also going to show you a little summary table each time we take a measurement here. So it's not like you're going to actually need to see what each one of these are doing. So back here on the table, I've already summarized that we've got glass, copper, 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 and then the copper comes in 3 sizes, small, medium, and large. And so what we're going to do is start off with a known volume of water inside each one of these graduated cylinders. We will tear that out on our scale. Obviously, we will write down what the initial volume of water was, and then we will pour the spheres inside of there, measure the new volume, so that would be the amount of volume displaced by the spheres, as well as what the mass reading is on each one. And I'll keep these summarized over here as best we can, try and keep the mic out of the way there. And then you can use these measurements in order to calculate what the average radius of the sphere is, as well as what the average density of each of the spheres are. And so as we go along, I will try to point out what our precision is for each one of these. Let's go ahead and get started with the glass ones up here. We're going to use the smallest of the graduated cylinders for this one. If you can see very closely on here, even if you can't, that's okay. The focus seems, there you go. Goes up to 25 milliliters in increments of about 0.02 milliliters. So that'll give us an uncertainty estimate that's on there. Let's go ahead and fill this up with a little bit of water for our copper spheres. So I'll pour a little bit of water in here. It really doesn't matter where we start with the water, but if we have a cleaner number to start with, that'll make life a little bit easier. So I'm just going to grab one of my pipettes here, so that I can top off my water. There we go. We are down to 13 milliliters here. So that's our initial amount. So I'll go ahead and add 13 milliliters to our initial volume for our glass spheres. Let's go ahead and set this on our balance right here in the center. Tear that off, so now that it's 0, and now we'll add 100 spheres to it, and we'll measure the resulting change in volume and the resulting change in mass. Go ahead and put that on there. There goes all of our spheres. All right, so our mass, which you probably can't see right about now, focus. It's focused on my microphone right now. How about that? Well, hopefully in a moment here it'll refocus. The mass that was measured on there is 3.4 grams, so let's go ahead and add that. So that's the average mass of 100 of these spheres. And now I'm going to look right up on the graduated cylinder here. And we are smack on 14 milliliters. So there we go. That's our measurement for the glass spheres. I'm going to go ahead and pour these out because we're going to need them again. There goes that one. And now we're going to move on to our, I'm going to put the microphone over here. Hopefully it'll stop focusing on the microphone quite so much. But we'll see. Go ahead and do exactly the same thing, except now we're going to do this with the copper spheres. So I'm going to add a little bit of water back in here. Should be good. Actually, that's a little bit too much water. I'm going to take some of that out. There we go. That's not bad. Grab another disposable pipette here. And I'm going to try to top this off again to something nice and even. And there we go. So we're topped off now to 10 milliliters on the initial value here. So I'm going to take this little fellow over here. We'll put 10 milliliters as our initial volume. And now I'm going to go ahead and pour the copper spheres inside of there, tear off my scale. Put my funnel up here, pour in. This is 100 copper spheres. These are the smallest ones. There we go. The smallest of the copper spheres. The other ones may or may not be bigger. And let's take a look at what we got. The mass that we're reading on the scale is 34.5. And the volume that we're measuring on there, let me grab my pencil over here. Let's take a look here. About 14.4 milliliters. So each one of these volumes are being read to the closest 0.2 milliliters. So I'll go ahead and add that as each one of my measurements here. We can go ahead and get rid of our copper spheres. We're not going to need those fellows anymore. There we go. Actually, we won't need that smaller one. And then we're going to move on to our larger copper spheres, which are actually, these are the medium-sized copper spheres. So we're going to add some water to our larger graduated cylinder here. This one goes up to 250, and it appears to go, let's see, in increments of, that would be 10, about 2 milliliters. So increments of 2 milliliters. However, the tolerance, which can be a little bit hard to see, right here at the top, you can see the tolerance actually says 1.4 milliliters. So this has actually been calibrated by the company to be a little bit more accurate than just, or sorry, a little bit less accurate than just plus or minus half of the smallest measurement. Yeah, because the smallest measurement is 2 milliliters. Half of that would be 1 milliliter. The tolerance of plus or minus 1.4 is saying it's actually a little bit less accurate than what we would initially assume. So I'm going to try to get this fella right up to about 100 mils. There's that. Let's grab a little bit more water inside of here. And we'll add a little bit more. We need about that much again to get us right up to about 100 mils. There we go. We're at 100 mils. I just managed to lose my disposable pipette in there. There we go. I really need that. So our initial volume, we're going to go with the medium-sized copper spheres here. Initial volume, we're going right up to 100. And this one, I'm not going to write any digits of precision since that seems inappropriate given what I just talked about with the tolerance on this fella. So we're going to set our 100 mils of water onto the Mettler, which, by the way, somebody got some blue dye down here. Thank you for whoever did that, because I've been wiping it off of my gloves for the last hour. It was more than likely me, but, you know, could be anybody. There we go. We're down to 0. We're now going to add 100 of our copper spheres. These are the medium-sized copper spheres. There's our 100 medium-sized copper spheres. The mass that we're measuring on the Mettler is 42.3. Oh, we just went to 42.2. And let's take a look at the volume displaced on here. We're up to 128 milliliters on that one. So we'll take 128 milliliters on here. There we go. Whoop. Try and move my microphone here so you can still see the numbers that we've got. That handles our small or our medium copper spheres. Let's go ahead and dump these out. Oh, we lost a couple. I'm sure somebody will find them sooner or later. And now we're just going to refill this with a little bit more water so that we can move on to our large copper spheres. That's pretty close to 100. Let's see what we're doing, just by coincidence. We need a little bit more to get us up to 100. There we go. That's right up at 100. Put that back on here. We'll go ahead and tear that out. I will write down that we have 100 mils to start with on here. For our large copper spheres, I'm actually just going to take this and move it over here since the microphone seems to work pretty well right there. And now let's go ahead and pour our large copper spheres in. These are the large copper spheres. Let's go ahead and put those in there. Remember, that's 100 of our large copper spheres. And our new mass is 127.1. Whoops, wrote that on the wrong one. 127.1. There we go. And let's take a look at our volume displaced. The marker grabbed my glove. There we go. All right, volume displaced. We're at about 192 milliliters now. That's the actual level that's in there, 192 milliliters. 192. Right, so from just this information, we should be able to calculate two things. We should be able to calculate first the average density of the particles that are inside of here, and second, assuming that they're all spheres of exactly the same size, we should be able to calculate the average radius or the average diameter of each of the particles in there. And I can hear you thinking that it seems a little bit strange that those giant spheres didn't weigh very much. And the reason for that is that these spheres are not actually solid copper. The only ones that are solid copper are these tiny spheres right here. So the small copper spheres, these fellows, they are solid copper. The larger spheres and the medium-sized spheres are not. I'm going to take this over to the vise really quick and crunch it just so that I can show you what's in there. So that loud pop you heard, that was this sphere getting pushed into the vise over there. Hopefully my camera will, there you go, focus on me. So if you look inside of that sphere, it's actually filled with plastic. So it's just a copper metal coating that's on the outer surface of this plastic sphere. So I would not expect that the density of the medium or the large size spheres to be anywhere near the density of the smaller spheres. These should be close to pure or straight copper, or at least the density of metal. So it may be a copper coating around something else, but it ought to be pretty dense compared to these spheres, which are plastic, or essentially plastic. These fellows over here, the glass ones, we know that they're glass, but we don't necessarily know what kind of glass. So we can't just look up the density of glass for that one because there's a lot of different kinds of glass. Which is why we made this measurement, but we can, of course, always use it to check our math later. So that should, again, be enough information to get, just from this data over here, the average radius of all of these spheres and the average density of all of these spheres. Good luck.